Elon Musk says that within 36 months, the cheapest place to run AI won't be on Earth. It'll be in space. Not Mars, not the moon, orbit. And he's serious about it. Because while we keep talking about AI models, GPUs and trillion parameter systems, the real bottleneck isn't chips, it's electricity. Musk believes we are about to hit an energy wall where there are more AI chips than power plants to run them. And if that's true, the next data center won't be built on land, it will be built in orbit. I know it sounds extreme, but Musk isn't talking science fiction. He's in fact talking about economics. But why space? And is he right? Let's break it down. On a recent episode with tech podcaster Dwarkesh Patel and John Collinson, president of Stripe, Elon Musk sat down to discuss everything from SpaceX and XAI to something far more ambitious, orbital data centers. All of it over glasses of Guinness Stout, just when you think serious tech podcasts can't get any wilder. The idea of orbital data centers didn't come from science fiction in that conversation. It came from a bottleneck. Musk's core argument is simple. AI is scaling exponentially, electricity is not. He believes the next constraint on AI won't be chips. It will be power generation. According to him, by the end of this year, chip production could outpace the ability to turn those chips on. Utilities move slowly. Power plant equipment is backlogged. Turbine blades and vanes have multi-year supply constraints. Permitting large solar farms on Earth takes time. Even building private power plants hits manufacturing bottlenecks. So in his view, scaling AI on Earth will hit a hard energy wall. And that's why space enters the equation. Musk argues that solar power in orbit is dramatically more effective than solar on Earth. In space, there is no atmosphere reducing output, no clouds, no weather, no day-night cycle, and no need for battery storage. He claims a solar panel in orbit can generate roughly 5 times the power of one on Earth. And when you factor in the elimination of batteries, the economics become even stronger. His prediction is aggressive. Within 36 months, possibly closer to 30, space could become the most economically compelling place to run AI. But that depends heavily on launch capability, specifically on Starship, SpaceX's fully reusable next-generation rocket designed to dramatically lower the cost of sending massive payloads into orbit. To make orbital AI viable, Musk estimates thousands of launches per year may eventually be required to deploy solar arrays and compute infrastructure at scale. Even then, power is only one side of the equation. You still need chips in enormous volumes. Musk repeatedly points to semiconductor fabrication as the next bottleneck. He says the world currently has roughly 20 to 25 gigawatts of compute capacity. To move toward terawatt scale AI, you would need massive increases in advanced chip production. He talks about building what he calls a Tera fab, a next-generation fabrication facility capable of producing chips at unprecedented scale, not just logic chips, but memory and advanced packaging as well. And he makes an important distinction. Right now, the constraint is electricity. But once space unlocks abundant power, the constraint shifts to semiconductor manufacturing throughput. TSMC, Samsung, and others are already moving as fast as they can. Advanced chip production takes years to scale. Yield curves take time. Equipment comes from a small number of suppliers. Memory manufacturing in particular may become a limiting factor. In other words, even if you solve power, you still have to match launch mass to orbit, solar generation capacity, and chip production volume. All three have to scale together. Otherwise, the system breaks at whichever grows slowest. Now, 36 months is an aggressive timeline. For this to work, several things would need to scale rapidly and in parallel. First, launch cadence. Musk's model assumes very high-frequency Starship launches. That would mean dramatically increasing rocket manufacturing, operations, and orbital deployment capacity. It's ambitious, but that's exactly what full reusability is designed to unlock. Second, space-based energy infrastructure. Solar arrays in orbit are more efficient, but they still need to be manufactured, deployed, shielded from radiation, and integrated into orbital networks. That's a large systems engineering challenge. And third, semiconductor manufacturing. Musk himself identifies advanced chip production as the next bottleneck. Unlocking abundant power only works if chip fabs can scale just as quickly. So the real question isn't whether space computing is possible. It's whether manufacturing, launch economics, and chip production can accelerate fast enough to meet Musk's window. But here's something more interesting. Musk isn't the only one looking at space as the next AI frontier. Google is exploring it too. Under what it has described as Project Suncatcher, Google plans to begin experimenting with space-based computing hardware around 2027. But the scope is very different. Google isn't talking about full-scale orbital data centers. The idea is to send smaller compute payloads, likely equipped with its TPUs, into orbit to test whether AI chips can operate reliably in space and run on continuous solar power. These would be experiments, proof of concept, learning missions. CEO Sundar Pichai has framed this as an early step toward a long-term possibility where space-based compute could complement Earth infrastructure, not replace it overnight. So the contrast isn't about who believes in space computing. It comes down to scale and speed. Musk is talking about industrial transformation, space becoming the cheapest place to run AI within 3 years. Google, on the other hand, is talking about validation first, iterate, test, then scale. In fact, startups like Starcloud and Crusoe are already experimenting with sending GPU-equipped compute payloads into orbit, including systems built around NVIDIA's high-performance AI chips. Axiom Space has spoken about modular orbital infrastructure that could eventually support cloud or data processing capabilities in low Earth orbit. And Blue Origin, founded by Jeff Bezos, has explored long-term visions of moving heavy industry and potentially large-scale infrastructure off Earth. None of these are full orbital hyperscale data centers yet, but taken together, they show something important. Space-based compute is moving from theory to experimentation. Different players are approaching it at different speeds, some with prototypes, some with long-term industrial visions. But the direction of travel is unmistakable. But one thing is hard to ignore. There is only one person openly talking about scaling orbital AI compute at industrial levels, and that's Elon Musk. This is someone who built a commercially viable space company, transformed the electric vehicle market, is developing brain-computer interfaces, and is pushing humanoid robotics towards mass production. So as radical as the idea sounds, if there's one person willing to attempt it at that scale, it's Musk. So obviously the real question isn't whether it's bold, it's whether the timelines hold. And that's something worth watching closely. If you enjoy such stories that sound like science fiction but sit at the intersection of technology and humanity, this is the space for you. I'll help you make sense of them. See you in the next one.